All right, the next equation with variables on both sides. We're going to attack this scary looking dude right here. He has fractions. Now, don't be scared of fractions. Instead, just be a fraction killer. Now, in class, most likely, we talked about equivalent equations. Now, when we are talking about equivalent equations, what that simply means is if you do like a multiplication, like you multiply everything by 5, or if we subtract 5 from both sides, you're getting equivalent equations. Okay, so you could think of like when you do inverse operations, you'll get equivalent equations. Well, also, if you do the same operation to both sides, you get equivalent equations. All right, so before we go ahead and attack this, let me review something really fast because, you know, sometimes we forget about how to do the fraction stuff. Okay, so if I had 2 over 5 and I multiplied that by 5, essentially what happens is you get 2. But let me explain to you guys why. When I multiply by 5, what we're doing is we're saying we want 5 of these. And if we want 5 of those, that would be 2 over 5 plus 2 over 5 plus 2 over 5 plus 2 over 5 plus 2 over 5. Now, nobody writes all that. We like shortcuts instead. But there's 5 of them, right? There's 1, 2, 3, 4, 5. Okay, so when we add all those, we keep the denominator because that's the rules with fractions, and you only add the numerator. When I add the numerator, that's 2, 4, 6, 8, 10. So I put a 10 right there. I get 10 over 5. And how does that simplify? No, wait a minute. You might be going, oh, Mr. Patey, why didn't you just, do that multiplication thing right across? You're right. I could have done that, but then I wouldn't have been able to show you why it works. So we get 10 over 5. And what does 10 over 5 simplify to? Now, 10 over 5 is the same as 10 divided by 5. They're the same, okay? We get 2, all right? So we're all about shortcuts in math. So if you guys see a shortcut here, take the shortcut, all right? Okay, so knowing all that, let's go back to our equation over here. Now, you'll notice that not all the variables are the same, or all the denominators right here are the same. So what we can do is we can look at the 8, 2, and the 4, and we can find our least common multiple. Now, what the heck is that? At least common multiple. Well, multiples, let's see, multiples of 2 would be 2, 4, 6, 8, 10, 12, and then it keeps going, right? We can keep going. Multiples of 4 would be 4, 8, 12, 16, and then we can keep on going. And then multiples of 8 would be 8, 16, 24. Each time we're just adding 8. Okay, so these guys right here are our multiples. Okay, least common multiples. Okay, so look at the 2, the 4, and the 8. What's the least common multiple? Now, it looks like 4 and 4 would be it, but it's not over here for the 8. So what about 8, 8, and 8? Yeah, you got it. 8 is our least common multiple. So what we're going to do is we're going to multiply everything by 8. All right, so let's multiply everything by 8. The first one, we have a denominator of 8. So guess what happens? The 8's cancel out, and we're left with 3z. Then we have 8 times negative 4. That would be negative 32. And then we have 8 times this. Ooh, okay, what's that? All right, now I would get, now you could just think half of 8. What is half of 8? That's 4. You're correct. Or I can do 8 times 1 and then 1 times 2, which gives me 8 over 2. And then this simplifies. What is 8 divided by 2? That is 4. Okay, so I don't need to write all that. I can just write 4. And then the last one, you see the 4 on the bottom? There is cross-canceling, so if you know how to cross-cancel, don't be shy. You can cross-cancel. So I get plus, that would be 3 times 8, and then 1 times 4. That would be, what is that? 24 over 4. And what is 24 divided by 4? That is 6. Okay, so we don't need to put all this stuff right here. Let's put our 6 right here instead of that. And you'll notice we had good news. No more fractions. Woohoo! Okay, so now we have to go back to everything we did to this guy over here. We got to get the variables on the same side, and we have to do inverse operations. So let's subtract. I'm going to subtract 3z because I don't like fractions. Okay, so that gets rid of the 3z over here. And then my new equation, my equivalent equation is negative 32 equals 4 plus 3z. Okay, next I'm going to subtract 4. Let's subtract 4 from both sides. What do I get now? I get negative 36 equals 3z. Now, I might have lost you there because there was a negative. We were having a negative number and we were subtracting 4. Don't forget, if we're at negative 32 and 0 is right here, and I subtract 4, that's 1, 2, 3, 4 this way, and that's going to be negative 36. Okay, so now we have 3z times 3 times z equals negative 36. So I'm going to divide by 3. That's our inverse operation. And then I get negative 12 equals 1z. All right, and that's our answer for that. Dig it out.